The following shows the graph of a system of equations. Find the equations. We have two equations shown, a red line that slants down from left to right and a blue line that slants up from left to right. The blue line contains 2 points shown, and we'll be able to find the equation of that line using those 2 points. The red line only has 1 point indicated, but let's follow this down and we can see that it goes through the x-axis right at 3, so the point 3, 0 will also be on the red line. And that information will be enough for us to be able to find the equation of that line. Let's start with the red line, and we will first of all find its slope. The slope is the rise over the run, or the difference in the y coordinates, 3 minus 0, over the difference in the x coordinates, negative 2 minus 3, which gives us 3 over negative 5, or negative 3/5. Now, a line has an equation y equals mx plus b, and we now know m. Y equals negative 3/5 x plus b. To find b, I'll take one of these points and substitute it for x and y. I'm going to use this point, 3, 0. I let 0 be y, and 3 be x, and now I can solve for b. We have 0 equals negative 9/5 plus b. Adding 9/5 to both sides of the equation, I have 9/5 equals b. I can substitute that now for the b and get the equation of the red line, y equals negative 3/5 x plus 9/5. Now for the blue line, I have these 2 points and I follow the same steps. I first find the slope, is rise over run, or the difference in the y coordinates, 3 minus 4, over the difference in the x coordinates, negative 2 minus 3, which gives me negative 1 over negative 5, or 1/5. Then y equals mx plus b. Y equals 1/5 x plus b. And now I have to solve for b. Again, I can choose either one of these points. I'll choose the point 3, 4, substitute 4 for y, and 3 for x, 1/5 times 3 plus b, or 4 equals 3/5 plus b. Then I subtract 3/5 from both sides of the equation. 4 is 20/5. So 20/5 minus 3/5 would be 17/5, and that equals b. Now that I know b, I can finish writing my equation. Y equals 1/5 x plus 17/5. And that is the equation of the second line.